Good Monday morning, grade 8s. How are you doing today? I hope you had a good weekend. The sun was out. That's always nice. Maybe today is a good day for you to look in your assignments and check back and make sure that you're all caught up, right? Start the week off fresh. So the last couple assignments that we've given you, I'm thinking about waves and tides and then erosion and deposition. You had a Google form for each of those two lessons. Google Forms are nice because they're easy for you to turn in, right? So they're kind of quick and you can go through them and it's a nice quick assessment for you. So that's why we're using those more than anything else. Anyway, you'll have another Google form for today's lesson. Today what we're going to talk about is basically the major forces that shape our Earth's surface. So we're going to start by looking at tectonic plate movement and how that shapes the ocean basin. A basin is another word for like a container, like a bathtub is a basin. So we're going to look at tectonic plate movements and the kinds of things they create. And then we're also going to look at glaciers and how glaciers moving over the land create a lot of landforms that we can recognize too. So our I can statement says, I can describe the processes which influence the shape of the lithosphere. And we'll refresh your memory with what the lithosphere is again. So, Monday, week 7, lesson 12. Let's get started. Okay, so the first thing is, let's have a look at what we remember from last lesson. So you have a do now question. Do you see two different rivers? One is coming from a very high hill. The other is coming from a flat area. Which river do you think will carry the most sediment? How do you think the shapes of the river might be different? So if you want to take a moment, you can just press pause and try that question on your own, and then we'll solve it together. All right, let's go solve it. Okay, so I'm going to bring up a slide I selected from last week. Now the key pointers in this question are the different heights that the rivers are coming from. So if it's a very high hill, then I know that the slope is going to be really steep and that river is going to be running really fast with a lot of force. If it's a pretty flat area, then the river is probably going slower. So we can review what we did here. So if it's very steep, I'm thinking this river would describe the first one, and maybe this kind of area would describe the second one. So which one could carry more sediment? It's going to be the one that has more force. So the one that's ripping around a lot faster, it's carving through and picking up and carrying more sediment than the other. The other, as it slows down, remember it starts to drop sediment and it might even start to change its shape. So for the first question it says, which river would carry the most sediment? It would be, our winner would be number 1. So number 1 would carry the most because it's of that force that it's got. How do you think the shapes of the river would be different? All right, so the shapes of the river are described here. So if it's going faster, it doesn't really have the option to go left and right. It's going to go fairly straight. The one that starts to slow down doesn't have that force carrying it forward, and it'll likely start to bend or wander or meander. All right, so make sure that you understand the big ideas from how a river starts and ends. Okay, movers and shapers of the planet is essentially what we're looking at today. And if you can make out what this little guy is, that's a bulldozer. So shaping the planet, pushing things along. Let's see how that affects our world. Okay, so we're going to talk about plate tectonics first, plate movement. And this is a refresher from grade 7. So when you looked at planet Earth, the very last unit in the year, you would have studied, you maybe even made a model of the Earth's crust and the whole Earth actually. So here's a little refresher on the layers that we're talking about. And when it comes to plate tectonics, sometimes they're called lithospheric plates. These tectonic plates are acting on this level, so on the outermost level. And the image beside it is showing you some of the major tectonic plates and their divisions across our world. So these plates, as we know, are shifting, and they've caused, because of that, they've caused some pretty major land masses and land formations to occur. They move by convection currents, so the heat from below the surface causing these plates to move, and the movement shapes the ocean floor as well as the continents. So we're going to kind of dive down under the water. We're going to look here at the ocean floor formations. All right, so here's a cross section of an ocean perhaps, and we've got some kind of neat formations that you might recognize. So here we've got volcanoes. We've got some volcanoes that actually come above the surface of the water, and we'll find that if a volcano starts but it doesn't quite reach the level of the water, it's another formation called a seamount. So a seamount is like an underwater volcano, and that's caused by the convection of the magma underneath. We've also got, I'm going to change my color. We've also got a trench we're going to talk about. A trench kind of looks like a slice, like a deep sort of cavern between two plates. We'll see how that forms. And then we've got an ocean ridge, essentially like an underwater mountain range. And we are also going to, I don't see a really good picture of it in this cross section, but if this was our area of land, usually there's this little area that sort of juts out before it drops off, and we're going to look at that as well. Okay, continental shelf. Around all the continents, around the major land masses, you've got a continental shelf. So where the shoreline is, it meets the landmass, but going underneath the landmass, you seem to always have this sort of shallow jutting out of land beneath the water before it literally drops off and hits the depths of the ocean. So this continental shelf right here, this is the area I'm talking about. We call it a shelf. Then at the end of the shelf, it sort of really drops off and you get into those real deep depths. Now in this shelf area, because it's more shallow than other areas in the ocean, like by shallow I mean maybe it gets to be only a kilometer deep. That seems pretty deep to us, but when compared to the rest of the ocean, it's more shallow. And because of that, you get a lot of light, right? Light can actually reach the bottom in lots of places. And because of that, you get lots of plants, you get lots of other organisms that rely on plants, organisms that rely on those, and you have a really, really healthy ecosystem there. So quite often, we'll say the coral reefs are one of the most diverse areas underwater with lots of different types of organisms. This is where your coral reefs will be found, is on that shelf. So lots of sunlight, lots of plants, lots of life. And warmth, of course, warm water. So that is what we call the continental shelf, and it surrounds all the major continents. Okay, volcanic islands. Volcanic islands are just like they sound. They're an island that has come from being a volcano, or was once an active volcano. So volcanoes that erupt on the ocean floor and whose tops rise above the sea level form these islands. Some of you have probably been to volcanic islands. Have you been to the Hawaiian Islands at all? Because those are good examples of this. So volcanic islands can come from the plate tectonic actions below the surface of the lithosphere. A trench forms on the ocean basin. A trench forms when you've got two tectonic plates moving toward each other, and it causes one the force causes one to go over the other. And in between those two, at the very point where they meet, they form these very deep crevices. And that's our trench. So here we could see our trench right in the middle of that picture. So the big idea is that the plates are moving toward to form these. And the way I always remembered it and help my students remember it is that trench starts with a T and toward starts with a T. So kind of cheesy, but hey, whatever helps you remember, right? Because the next formation is going to form from plates moving away from one another. So just remembering which is sometimes tricky. So pretty great picture here. There's lots to take in. You can see the continental crust, you can see the magma below, and sort of leading to the movement and shifting of these plates. The word subducting means to go under. So that plate that gets forced down is the subducting plate. All right, but again, that's extra. Okay, mid-ocean ridges. Now this is the kind of formation that gets formed from plates moving apart. So two tectonic plates moving apart from each other or diverging, so again going away, they will split. They cause this sort of split in the mantle, and because of that, the magma wants to come through there. And as it does, it's very, very cold at the bottom of the ocean, and that magma solidifies. And it's very bubbly, very bumpy, and it ends up sort of looking like mountain ranges on the bottom of the ocean floor. So a ridge is essentially two plates moving apart, and they form these mountain ranges there. All right, trucking along. Seamounts. A seamount is an underwater volcano whose top did not break the surface of the water. So lots of times you have these sort of underwater looking volcanoes or masses that have rich ecosystems, and again they're not even seen because you can't see them below the surface, but they exist and there's lots of them. Often they come up near ridges, so due from the activity of the convection currents. Cool. So seamounts are kind of like the volcanoes, but they're just on a smaller scale. They don't peek through the top of the water. All right, this image shows you kind of an overview of everything. So this is an ocean floor, the basin of the ocean, and we can see lots of different formations we just talked about here. Some we have to know, some we don't. But for grade 8, I'll just circle the ones that are in our curriculum. So we've got the continent, of course. We've got the slope. The continental shelf that juts out into the water, that shallow, ecosystem-rich area. We need to know that one. The slope, maybe I shouldn't have circled that because I don't think we would, even if we were in school, we never test you on the slope. Volcanic islands we do, so we can see some of those there. We see that sort of mountainous looking ridge from plates moving apart. We see a seamount, but again, seamounts don't typically reach the top of the water, so I find this picture a little deceiving on that. But we do need to know seamounts, and then we've got our trench there as well. So 1, 2, 3, 4, 5 that we looked at with that. So not to forget that tectonic plates are very active in creating the formations above ground too. I think you looked at mountains and that in grade 7 more. Water flows from high to low elevations. So we can thank the plate tectonics for their hand also in helping us form our land masses, form our different watersheds in Canada, because wherever the highest area is, it's going to dictate which way water flows. And we talked last week about continental divides, ours being the Rocky Mountains, but that highest area of land that causes water to flow away from it. So in this picture, we can see this red line that's showing us where the Rocky Mountains are heading down. So the highest area of land, and of course causing water to flow away from the highest point. So our drainage patterns are driven lots by the movement of plate tectonics. The movement of the plates causes water to drain in the areas and the patterns that it does. All right, so that's our little talk on plate tectonics. Let's look at glaciers now. Cool stuff. Maybe some of you have taken a trip up to the Columbia ice fields up in our Rocky Mountains and seen what's up there. I mean, we could do a whole lesson on the glaciers alone. There's so much to see about that, especially with our changing climate and the fact that glaciers have really changed over time. They've receded and melted a lot, and we can see it in simple photo evidence. Glaciers going back, so here we're going to look at a few thousand years ago. Our whole North American continent here was covered in a big sheet of ice. So what I wanted to show you is a couple little videos. One I can show you in our lesson right now, and that's this one. Glaciers, of course, were very important in shaping the surface of our land. They're heavy. They're moving like a giant bulldozer. And glaciers have even been called that at times because of the kinds of formations that they leave. So I wanted to show you a video here, this one. And just look, it goes back, let's see here, maybe 20,000 years ago. It looks at how the glaciers that once covered Canada have receded or melted. So let's have a look. Watch in particular along the edges at how the water changes as it's melting. So in some places it almost advances and then retreats, or advances and then retreats, but overall it's warmed up and our ice has melted away and left a lot of cool things behind that we're going to have a look at next. All right. Over time, this glacier has retreated and melted, gave Canada many of the major bodies of water that it has today, and it's carved out the landscape that we see. Glaciers have been very impactful in their force in shaping our Earth. So this is actually a little diagram of the ice sheet that you just saw melting away, the Laurentide ice sheet, and you can see where it once was has now left us lakes. So for example, that's going to be one of the land formations, the features that glaciers can leave behind as they melt. All right, so how do glaciers move? I found a really cool video that shows us glaciers moving. Now, glaciers are ice, and it's hard to see ice moving, but this video shows a time lapse that just kept taking photos of the same areas, and over time, over days, you can see it moving. So I'm going to actually show you that little clip between 42 seconds and a minute 15 in, and so that you can see that. The second thing that I liked about this is that the lady in this video goes into a glacier. So you can actually see how glaciers are different from the bottom of them up to the top of them, and the bottom how it's running, how the water is literally running under the glacier. So it's melting at the same time as freezing on top, and creates all sorts of dynamic changing things with the glacier. So let's see how this time lapse works here. Check this out. So again, these are photos taken over a section of days.
A time-lapse camera shows that Nigod's Plains surface ice travels at around 275 meters per year, carving away the rock as it goes.
Pretty cool. So I encourage you after this to go and click on this video and watch it in full. It's not too long, but it'll show you some really neat things about a glacier and how it can possibly move. Okay, so let's look at some actual formations made by glaciers. So glacial features or landforms. First one we'll talk about is a rolling hill. So rolling hills are these nice smoothed out sort of, I don't know, I guess they've kind of been like rounded off mountains. So think of a glacier as a big heavy sort of bulldozer, and it's moving over these rough rocky edges and just smoothing them out like sandpaper. That's what rolling hills end up looking like. That's a nice picture of that. The other thing is here is U-shaped valleys. So where you've got the smoothed out hills, you've also got the smoothed out valleys, but the unique thing here is that they're shaped more like a U. So an actual, let's put this here, like an actual U, not a V. Now rivers that cut through land usually form V-like shapes of that formation. Oops. But glaciers, because of that grounding out of the lower area, you end up having more like a U shape. U-shaped valleys. All right, maybe a new word to you. A moraine is a deposit of rock and gravel that's been left behind, usually along the sides and along the bottom of a glacier. So here we've got, we see some moraines along the sides. There's even one in the center. There's lots around sort of the foot of the glacier. In the real life photo on the right, here are some moraines. And I'm sure we could pick out a few more in this area as well. I mean, for me, if I was teaching this in class, I probably would have dumped a big bag of Lego on the counter. Because Lego is kind of like big chunks of ice and gravel. They could be whatever. Me, the bulldozer, the two hands coming through, pushing through that Lego. If I were to push a path through the Lego, I would see that where my hands have pushed through, I've also got sort of a pile up now of the Lego on either side. Why am I thinking Lego? Because my kids' rooms right now, you can barely touch the floor in one son's room because that's all they've been doing is Lego. And that's good. I mean, Lego's awesome, but lots of Lego going on. But if you push through it, it's not a smooth, clean push. You're going to get a lot of pile up of rock and gravel along the side of this. So it's kind of a lot like that. They're big hills of gravel on the deposits that's being pushed aside by that glacier. All right. An esker. This has to be my favorite because they're so unique looking. So what an esker is a winding deposit of land. It kind of looks like if a river could be made out of dirt, this is what it would be. It'd be an esker. And it's been formed from the melting running water that's been going underneath the glacier. What? Okay, so remember back to that little video that I showed you with the glacier, and I was telling you that underneath the glacier, you've got meltwater. So it's literally moving along water, and water's going to run downhill. It's going to run along the same path all the time. And as it's running, it's dropping minerals. It's dropping gravel. It's dropping whatever it was been carrying. So it's over time, it's kind of creating like a pile of minerals. Well, once that glacier disappears, what's left? You see these streaky little snake-like areas where water had once been running. Here's an actual, I like this next picture as well, because you can see these winding hills of land formed where water once ran under glaciers. They build up from deposits, and once the ice melts away, they look something like this. So here you can see a very long, winding esker pattern. Some more here. Whoops. So very cool. Eskers are kind of like rivers made of land. They look like that. Okay, a drumlin is a unique little hill. Kind of like the rolling hills, but drumlins are more teardropped shape. So they have this shape to them. And they point in the direction that the glacier is moving. So here's a side view. We've got this hill here, and the narrow end of this hill is the way the glacier was moving. So here are some more drumlins that have been formed. Here. I can't tell really from this picture, but these two are really distinctive features. Drumlins, teardrop shaped hills. And as the glacier is moving and sliding over, they're getting cut out. Now sometimes big chunks of ice, huge chunks of ice, break off. And where they break off and they melt, they form kind of like an instant lake. So you have lots of formations of kettle lakes forming in areas where glaciers once were. Some cute little circular, very circular pattern for the most part. Kettle lakes. Holy moly. So lots of vocab, lots of like specific items that we just looked at in this lesson. The two big ideas are in different colors here. So the first one, we're all features that are changing our landscape by tectonic plate action. The second one, new color. The second one are all features that change our landscape, but by glaciers. So, have an idea about the two major forces that I went over here, and also have an idea of some of these individual examples under each force. All right, they're not all vocab words. We've taken some out, but your vocab words include continental divide. You know what? I think that should say continental shelf. And I will change that on the original Google slide. Divide was from last week, right? So continental shelf was new today. The trench, the ocean ridge, a moraine, an esker, and a drumlin. So 3 from each different force that we looked at today are your vocab. Okay, looking ahead, same drill. We have a Google form for you. So we'll get you to go do that assessment next. Go into your homeroom classroom, go under your e-assignments, and do your Google form for today. See what you remembered. And coming up Wednesday, I believe that's climate. We're looking at climate and something else that I forget. Anyhow, come see us in video chat today. Maybe we'll do vocab words. We've been doing some Pear Deck vocab where you guys get to like write your own vocab cards, and it's an interactive game. So come and check it out. If you don't like it, don't stay. But it's fun, and usually there's about I don't know, a handful of regulars that come in. But if you're looking for something to do and you are up and awake at 10:45 today, just go into this Google Classroom or the grade level Google Classroom, and up at the top you see the Meet link. Like, do you know how to access that? I don't know if all kids do. And why don't I try to show you while I have you? So I am a part of many Google Classrooms, but if I just click on my grade 8 science one, there it is. Okay, so that link will become live at 10:45. So you can just click right there. And it'll also be live again at 1 p.m. today. So come and see us, and I hope that you have a great day. Hope you have a good week. All right, we miss you. Thanks.